Okay. Thank you for inviting me to speak on the topic of the status of embedded Linux. I apologize that I'm not delivering this in Japanese. Your English is better than my Japanese. Um, I've given this talk quite a bit before. I know some of you have seen it, but just a reminder, this is I just periodically I take a look at the status of embedded Linux. This talk is not comprehensive about everything that's going on. It's just a few of the things that I have seen recently. There's no way to cover everything, so I apologize if I missed something that you're interested in. A lot of this talk is going to be focused on things I heard or saw at recent events, particularly Embedded Linux Conference in Vienna and Linux Plumbers. I went to both of those conferences, and so you'll see a lot of references to talks or to micro conferences. But there are a couple of other resources that I looked at. This is the overall outline. So I'll talk about specific kernel versions and then go into technology areas, give just a little bit of industry news, talk about some community resources, and then some conclusions. So let's start with the Linux kernel. We just had a release of the 6.11 kernel. You'll notice over the past year we've had, what is that, about 8 releases of the kernel. They're fairly consistently coming out at about 9 weeks each. Every once in a while, like the 6.7 kernel was over the holidays, so understandably a week longer on that one. But the kernel processors are very well developed. It's been going like this for several years now. So we're currently this week, we're on release candidate 1 of the 6.12 kernel. That means a week ago we had the merge window. Merge window lasts for about 2 weeks. I would expect the 6.12 to be available on sometime in November, probably November 16th. It could be a week later than that, but pretty consistent. So let's look back at the kernel versions that we've had in the last year, at some of the things that I thought were interesting. So for Linux version 6.6, which was a whole year ago in October, you can now build a kernel without buffer head support. So this is something that's been going on in the in kind of the file system and memory area. Uh, there's been an effort underway to eliminate the buffer head subsystem. And so the only reason for bringing that up in the context of embedded is that if you are using an older file system that depends on the buffer cache, this is something you may want to watch out for when you upgrade your kernel to 6.6 or later. There's a new event FS subsystem that improves the memory efficiency of the tracing subsystem. And the way it does this is it only allocates the inodes and D entries for trace points when they are needed. And then shadow stacks was added. This is the first version of the kernel that had shadow stacks, and I'll talk about that. So shadow stacks provides an alternative stack for return addresses. So you can put the return address on the regular stack and on the shadow stack. So the normal processor flow just looks at the regular stack, but you can have this secondary stack, and then on return, the shadow stack can be used to see if someone has been messing with the regular stack. So a very common kind of attack, security attack on the kernel is a return-oriented programming attack, or ROP attack, and where they get the control of the kernel, the instruction counter to go somewhere other than where you intended by messing with the stack. But with the shadow stack, you have basically a backup, and you can detect this type of attack. So the x86 support for this landed in 6.6. There are patches for 64-bit ARM and RISC-V. I thought they would be in by now, but I just saw this week version 13 of the ARM64 patch was posted this week. So I guess they're still not haven't been accepted into the kernel. Looks like it's taking a while to get the ARM support for that. They're actually called something different on ARM. I think they're called guarded stacks. Anyway, but the work for shadow stack support was put in the Muscle C library, and it's already been in GCC for a while. Anyway, that's something to watch for in future releases. Um, in Linux version 6.7, it turns out that you can disable 32-bit emulation when you're running a 64-bit kernel on the kernel command line. This reduces your attack surface somewhat. That emulation allows you to run older binaries or binaries compiled not for 64 bits. And turning that off removes some attack vectors. The Itanium architecture was removed in this release. There was a little bit of more efficient same page merging that was added to this release. And then PrintK had some changes to now support per console locking. And this is part of the work that was for the real-time patch set. There have been quite a bit of PrintK work, and I'll talk more about the real-time patch set in a little bit. But this particular feature allows high priority messages to be output, or a high priority message output to take over the console, so you could they would have higher priority than lower priority messages. So anyway, you can read up on that in the lwn.net article listed there. In Linux 6.8, deadline servers were added. And this is something that helps prevent starvation of normal tasks. Or actually, it's a little bit, there are some other mechanisms. I think I have a page on this, so I'm not going to go into details here. But anyway, the first real Rust driver was added to the kernel. So Rust has been, people have been working on Rust for several years now, Rust support in the kernel. And in fact, at Plumbers, there was a whole micro conference on Rust support. But the first real driver, as a reference driver for ASICs PHYs, was added to the kernel in March of this year. The network core data structures were refactored for better cache efficiency. So in some situations, this improved the performance up to 40%, which is pretty impressive. The slab memory allocator was removed. That's amazing to me. I can remember when slab was the only memory allocator the kernel had, and then they added two other ones. But now this is the original memory allocator inside the kernel. Well, for object-oriented memory allocator has now been removed, and so slub is the last one remaining in the kernel. And then perf data type profiling was added, and I'll talk a little bit more about that as well. So on the topic of deadline servers, so what is this? So deadline servers is a way to provide a mechanism to prevent real-time tasks from starving. So there used to be a feature, well, I think it's still there, called real-time throttling. But this is a little bit more efficient. And how this works is that there is a deadline scheduling priority in the Linux kernel that's even higher than real-time priority. So you have your normal priorities, normal scheduling priorities, and real-time priorities, and then the deadline scheduling is even higher priority than that. So if you have a task running at that deadline priority, then it will actually take precedence over any RT tasks. So the reason this is good is that when it runs, well, you can have a deadline server is set up, and it can detect when we're starting to see task starvation. So if your real-time tasks are interfering with your normal tasks, that's not a good situation. And so with the deadline server has a guaranteed quanta. So not even the real-time processes have guaranteed quantas, but the deadline server does. And so it takes up very, very little. It's not activated until that starvation is detected. So it consumes a lot less resources than the real-time throttling feature did in terms of the overhead of implementing it. So this is an improvement for RT. So that's a nice feature. The other thing that came in this release was perf data type profiling. And this adds a new subcommand to perf, perf annotate dash data type, or just dash data type. Anyway, you can get sample data per field in a data structure. So this is really handy. It's very useful to see if how often your fields are getting accessed, and if by moving your fields around, you can actually improve cache performance. So there's been a lot of work to try and improve the efficiency of the kernel by restructuring, by reordering fields inside the structures so that you hit cache lines more effectively. Make sure that all your frequently accessed fields are in the same cache line. So this is not super new. This is on this particular version of the kernel from March, I believe. But there was recently a really good talk on this. This one was not. This one was at Kernel Recipes. So Arnaldo Carvalho de Mello gave a talk on this, and there's a video and slides talking about how this was used and some other techniques that people are using to improve the cache performance of the kernel. So I recommend that. And this talk just came out. This was done just like 2 weeks ago or 1 week ago, maybe. And then in the 6.9 kernel, we had the ext2 file system was actually marked as deprecated. So if you have that type of file system, it'll still be handled by the ext4 module, so it's backwards compatible. But the standalone ext2 file system implementation is now deprecated. So I suspect that's not a problem for many people, but I don't know. Maybe you have a super old system and you're worried about that. There is faster timer setup. It just blows my mind that they keep coming up with ways to improve the performance of code that's like 20 years old. Anyway, so someone noticed that they were doing CPU timer selection or CPU selection for a timer at the time when the timer was created, and they realized, well, since most timers don't expire, that's overhead, that's work that doesn't need to be done, and is often wasted CPU cycles. So now they select the CPU at timer expiration instead of timer creation. So got rid of some wasted cycles. There was also in this release work on reducing network stack contention. There's a kernel energy model that can be updated at runtime, and there were some security mitigations having to do with a vulnerability on Intel Atom called register file sampling. So there's continuing security work all the time on the kernel. In the 6.10 release, there's continuing improvements for Rust support. There's the ability to do encrypted interaction with the TPM. I think so. The TPM is for storing secrets and doing validation of kernel and user space items. But it turned out that the communication channel in some instances between the kernel and TPM was not secure or was not encrypted. So that seems like that's an oversight. So that just improves the overall security of the system to have that when you're transferring those secret credentials and cryptographic hashes and keys and stuff, it's good to do it over a secure channel. Something also related to security had to do with cryptography stats. Apparently, no one there was for a long time the kernel has been measuring kind of details about cryptography that no one was actually using, so they removed that. So, and it was both a runtime overhead to keep track of those stats and a maintenance burden. Every time they made crypto changes to the crypto APIs, they had to update this statistics code, but they realized if no one's using the statistics code, then that's just interfering with maintenance. And then they removed some of the early alpha CPUs. I just want to comment on that. So the early alpha CPUs, this was the first non-x86 architecture that Linux was ported to. I can remember back when I think it was John Mad Dog Hall he worked at DEC at the time. He helped Linus make Linux an operating system that worked on more than one processor family. But those early alpha CPUs did not provide byte level memory access. So they were a little bit weird in how the addressing worked. So Linus has said, well, it's a bit sad to see the support for my first alpha go away. If you want to run museum hardware, maybe you should use museum kernels. Okay, so I suspect none of these are actually in production use today. And there are kernels that support these CPUs, just not the current one. So it's understandable that that kind of support would be removed. Um, and also in Linux 6.10, and this was released in July, was memory allocation profiling. And so this is something that's pretty interesting. You can track all of the memory allocations in the kernel and what code did that allocation. It's very useful for debugging memory usage. So there's a feature called code tagging, which was also added in this release that supports that. So now that that work is upstream, the people are working on tuning the overhead of the profiling to make sure that it's doesn't have as much very little low impact. So you can do this profiling and keep track of figure out if allocations are getting lost or you can do all kinds of things to improve the both the performance and kind of the security of the allocations. Make sure you find out where your leaks are, obviously, very quickly. So in 6.11, which was just released in September, so we just had this. And so this is stuff that's pretty new. There's a new power sequencing subsystem, and I'm actually going to talk a little bit more about that later. But the basic idea is that you can bring the system devices up in the right order for power management. So I thought it was interesting that the feature went into 6.11, but the documentation didn't go in until 6.12. So it was a little bit lagging on the documentation, but it's there now. It made it into the merge window. So also something that caught my attention was someone, I can't remember the name of the developer, did the sloppy logic analyzer. So you can actually use some GPIO lines in a kernel as a poor man's logic analyzer. So it sets up, there's some tools that you can do that and use those to sample the GPIO lines, and it saves it into a buffer just like a regular logic analyzer. Of course, there are limitations on this because you've got all this other stuff going on. So there you would expect kind of some jitter and things to creep in there. But for low resolution sampling, it works okay. So that's something to look at if you don't have Logic Analyzer and you happen to have like a Linux sitting around. And another thing that I caught my attention in this release was a new runtime const macro. So the Linux developers, they're very interested in performance. So it turns out that in some cases, actually using a variable, actually getting a value out of a variable is just too slow. So what the runtime const macro does is it takes values that are not known until runtime. So you figure out the value of something at boot time, and it never changes over the life of the kernel. And so over that instance, that particular run. And so it takes that variable value that wasn't a variable and it then hard codes it into the instruction. So it makes it into like an immediate instruction. So there's no memory reference in order to use that. Well, it's now a constant. It turns it into a constant. So it takes a variable and turns it into a constant. And so right now, this is only used in one place. It's for the de-entry cache, which I think is one of the hardest, one of the most important time critical things in the system. Is the de-entry cache is used for basically every file system lookup, and so it's only used in one place now, but I wouldn't be surprised to see other people start to use this. Unfortunately, it's currently undocumented. So we'll have to see if that can get documented, and then maybe people will start using it other places. It's pretty tricky to use, though. I have to say. Anyway, well, I mean, not. I guess once you understand it, not too bad. But another thing that had to do with speeding up things is VDSO implementation of get random. So you can get a random number out of the kernel with a syscall. But of course, then you have the syscall overhead to do that. And so there are a couple of operations you can do that kind of you can do from user space. So the most common one was there was a get time and get time call, get time of day, I think that they moved so that you could perform that operation completely.
Someone's at the front door.
Oops, let me turn that off. Um, so so some of these operations can be done from user space, and now you can do a get random from user space. So not incur the overhead of a syscall to get your random numbers. So that will speed up. There's some applications that do quite a bit of random number generation. The side effect, this is interesting because the side effect, they wanted to do this in a way, as part of this, they needed an area of memory that they could drop, that they could dispose of once they were done with it. And there was a lot of, actually, the thing that held this patch from going in was it had its own special mechanism for dropping some memory. But they said, well, why don't we, it seems like a useful thing in general, so why don't we just make a new flag to the standard mmap. So they've added a map droppable flag to mmap. So when you memory map some memory for the kernel, you can now specify that the kernel is allowed to drop that whenever it feels like it. And you have to be able to detect that on the user space side and deal with the problem with that. It sounds like it's kind of a dangerous thing, but in some circumstances, it's quite handy. Allows the kernel to reclaim that memory without worrying about what the user space was doing with it. And then in red there, I've got the extensible scheduler class was not added this release, and I'll talk about that more in a minute. Okay, so 6.12, we've had the merge window, so this is the stuff that we expect will be in this. So preempt RT was enabled in this release, and I'm going to talk a whole bunch about that. That's very exciting news. There were some more print K improvements that were related to that. There's the security module system now uses static calls. So another case where using indirection, this is very similar to the runtime const thing, where instead of with variables, it relates to function calls. So there's a whole lot of code in the kernel that uses indirect function calls. But for the security code, they really want it to be as low overhead as possible. So even though they may be loading securities as modules, and that would imply that they have some indirection involved in their function calls, they can replace those indirect function calls with direct calls by writing the code at runtime. So they're replacing actually the calls through the jump tables with direct calls by modifying the instructions inside the module at runtime. So it seems like the Linux kernel recently has been on this kick where they're rewriting their own code at runtime, which for performance reasons. So that's pretty interesting. Also, there was some work on making the tracing ring buffer that persists across a reboot, and I'm going to talk about that a little bit later when I get to tracing. And then in integrity policy enforcement, a security module was introduced. So this is a module that checks integrity. It's a security related module, and you can go look up the details on that. I don't think I did this. Okay, so let me talk a little bit about SkedgeExt. This was added in the 6.12 release. So I said it was not added in the 6.11 release, but this is the extensible scheduler class. So SkedgeExt is kind of the name of it. But what this does is it supports pluggable schedulers using BPF. So you can write a scheduler outside the kernel and plug it in at runtime while the kernel is running. And you can actually add these in, enable them, disable them, remove them, just like you would with any other BPF script. So So Linus has said that he was going to merge it in 6.11, but there was a lot of kind of pushback on that. People wanted, and so there was about well, turned out not to be a 3 month delay, about a 2.5 month delay. And you can go read up on kind of how these work, and you can actually go see some sample BPF schedulers at the GitHub. So this is interesting because this is scheduling code, which is scheduling is a core function of the kernel, but it allows people to do kind of very experimental schedulers, and particular high-end systems, like high-end server systems use this type of stuff when they have very specialized workloads. So Google uses this quite a bit for their search. They've been using this for a while, actually, this extended scheduler. This was so interesting that, let's see. Oops, what did I do? Oh, I pushed the wrong button. Okay, let me see. I got to get back to where I was. Sorry about that. Oh, wow. Okay, back into the kernel. Okay, there we go. Wow, okay. This was such a hot topic recently that they had a whole micro conference on it at Plumbers. And I'm not going to go through all the details of all these different talks. The only reason that I bring this up, because this is mainly a feature that's used for server and enterprise workloads, but you'll notice the third presentation there, use SkedgeX to improve frame rates on the Steam Deck. So there are, I believe, specialized workloads we might have in the embedded space. So the Steam Deck is a kind of a video game console that's running Linux, and so there are cases. I think there are use cases for having a customized scheduler. So if you're not happy with the regular scheduler and you want to kind of play around with it, you now have the opportunity as of 6.12. And my observation is, I did look through some of the material here. These scheduling developers, man, they are pretty intense. It is they're really counting the cycles and looking at how stuff is getting scheduled. This is just an overview of the kernel releases. So that was a quick overview. Well, maybe not super quick, but we're currently on RC1. We have the long-term kernels from 4.19 through 6.6. I would expect we'll get a long-term kernel announcement here sometime soon. Probably in time for Open Source Summit Japan, we'll know what the next long-term kernel. I don't know if it'll be which of these it'll be, either 6.10, 6.11, or 6.12. I suspect it'll be 6.10, but I'm not sure. They tend to be about 5 or 6 apart. But notice that 4.14 has got dropped off, so it's not being supported upstream anymore. This is just a chart showing contributions by embedded Linux companies. The things in red are kind of the things that have changed since the last time I showed this. There's quite a bit of overlap, and actually that should be commits since September of 2023. So this is kind of a sliding window. For the last year, these are kind of the commits that have been done by various companies and projects. So Linaro has quite a few. You see, there's this one. I noticed that there was quite a bit of work on the IIO subsystem, which is the industrial I/O subsystem, and then in Pangotronics, Uwe Klein-Koenig did a lot more driver cleanups. He gets a really high patch count because he does these driver cleanup things. And Krzysztof Kozlowski with Linaro also does a lot of cleanup work, but he does a fair amount of regular of DT and other work as well. One resource that I stumbled across, I don't know if everybody already knew about this. I don't know how long this has been around, but I just stumbled onto it myself in the last couple weeks. And it's called the Kernel Source Database. This is a service that is provided by lwn.net that you can go in and they will analyze commits, contributors, and employers for every kernel release. And I'm pretty sure this is a database that is automatically generated from Git commit data and that John Corbett uses when he publishes his articles on kernel stats. About every 3 or 4 releases, he will publish an article on kernel stats. Anyway, I've just started using it myself, and it's really interesting. You can see charts. The main thing I used it for was to see when I'm looking up what an individual developer has been working on. It shows a very complete history for each individual developer. So if you want to see what I don't know what Andrew Morton's working on, or any developer in a particular area, and it shows you release by release what tags they were in, what things they authored, what things they signed off on. And it also, unfortunately, it's only available for subscribers, but that's okay. You should, if you're not already an LWN.net subscriber, you should subscribe. That's my plug for them. This is one of the charts that is available there. It shows you the number of commits per release, going all the way back to 2.6.15. So you can see we're averaging, somewhere in the range of 13,000 to 15,000 commits every release. That downward line right at the very end there, I think that's just because it has not picked up that's probably the merge window for 612. It takes a while for the merge window to shake out the total numbers. Anyway, but I think the really interesting thing here is the developers per release. So we're consistently up around 1,800 to 2,000 developers every release, and about 200 to 300 of those are new. So there are people who leave kernel development, but there's a pretty steady group of people that are involved in every release, and there's new people every release. But we have a very consistent total number of developers every release, which is pretty amazing for how big a project the Linux kernel is. The other thing I just wanted to mention really quick, I think this is my last slide on the kernel. Yeah. So, is tools for kernel developers. So Konstantin Ryabtsev has, he is the person who's in charge of the lore email archive. He's also the author of the B4 tool. And he gave a talk at the Maintainer Summit, which was also in Vienna. And so you can see kind of the LWN.net article on that. But B4, he's working on a new B4 review subcommand. So this there's B4 is being used quite extensively now by a lot of the kernel maintainers to manage their workflows. And another thing that he's been working on is called a bug spray bot. And this integrates the kernel Bugzilla database into a project's mailing list and Git repos. So some kernel developers don't like Bugzilla. They just want to manage their bugs manually, or some of them even have other systems. But if a maintainer is using Bugzilla, then there's this automated bot that will watch for changes and will send reports or send emails and reminders and things like that. And then in terms of the lore email archive, the thing that caught my attention here is he's working to provide pre-filtered email boxes for specific subsystems. But he's also looking at AI. So he may implement an automated what's new summary generator for the different email archives. So that could be quite interesting. So we may be getting some generative AI on our kernel mailing lists soon. That will be interesting to see if that happens. Okay, so that's it for the Linux kernel. Let me go over some technology areas. I've got to pick up the pace a little bit here. So I have this kind of leading slide here. So I don't have a link to every presentation or every session that I mention. There's kind of too many, and I'd be links all over the place. Sometimes I just have a title. If it's for Embedded Linux Conference Europe, you should be able to find the slides and the presentations on the eLinux Wiki, except not today. So this is not populated yet. It should be populated within about a week or two. Actually, that'll be something I'll be actually working on tomorrow, is populating the presentations page. So give it a day, and by next week, hopefully you should see at least the slides up there, and then as soon as the videos are available there. But in any event, if I just have the title of a presentation, you should be able to find it there. And then the same thing with for plumbers. Uh, Sometimes I will refer to a plumber's talk without giving the individual link, but you should be able to find the slides by searching on this link that I've got on this page is the detailed timetable, the detailed schedule that shows like all 255 talks. And so you can search on that page for a title and or an author and find the session. Okay, so let's talk about some specific areas. So this I've recently got re-involved with boot time. There were some pretty good talks recently. One of them was at devconf.us called Accelerating Linux Boot Time Techniques and Strategies for Alpha Performance. This had a really good list of techniques. These developers, Eric Curtin, Ed Chong, and Brian Masney, are at Red Hat in their automotive group, and they had a long list actually of techniques and patches and things that they're working on. So that is worth looking at. Um, Kasim Syed Mohammed is with TI, and he has been talking about productizing Linux boot time tweaks and tricks and engineering problem. And so that's also a good talk to look at. And then I gave my own talk. I did some work over the summer on boot time reduction. So some of the initiatives I've been working on were, I think, do I have this on? Yeah. Well, I'll go over that in a sec. So I did boot time markers, boot phases, and profile guided optimizations. I gave this talk at Plumbers. So we had a whole session at Plumbers on this. Some of the current work going on with boot time, there's a lot of people working on it. So TI is working on streamlining the firmware startup in multi-core environments, and particularly for secure environments. Uh, it turns out that when you're doing secure boot, you touch the bytes of the kernel and the modules quite a few times because you have to run cryptographic hashes over them and stuff. And so they're coming up with ways to reduce that overhead. And then also, they're very interested in generalizing the handoff of firmware initialized hardware to the kernel. So one of the problems you see is that you may have to start the camera, or you may have to start like the Ethernet bus before in from firmware. So you have U-boot do that, and then it's already initialized. You don't want to have the kernel reinitialize it. So they want to come up with a generalized mechanism to hand it off to the kernel and tell the kernel that it's in a pre-initialized state. Qualcomm is working on deferred memory initialization. Red Hat is working on a bunch of stuff there. You can read those. And I would recommend, if you're doing boot time, you should look at Red Hat's presentation. I've been working on boot markers and boot time regression testing. And then I've got deferred init calls. I've got a patch ready to go upstream here pretty shortly. I'd like to start working on a boot time tuning tool. I've discussed that at Plumbers with other developers. And then Collabora has also been working on a boot time testing regression test for CI using ftrace. So there's a lot of work going on with boot time right now. So the next steps, though, is even though a lot of different people are working on things, we're not collaborating. And so we had some discussions at Plumbers about where we should be collaborating. So for now, I'm going to be using the eLinux Wiki for sharing my information about boot time. I'm trying to try and collect up these presentations and some of the techniques and put them. It'd be nice to collect a bunch of this work into some kind of guide, boot time tools and tricks guide that maybe could go upstream. But in the short term, we're going to use a wiki. And we agreed to use Linux-embedded at vdr.kernel.org for our boot time discussions. Someone has to lead this. I'm not sure if it'll be me. I will probably start some stuff off, but I don't know if hosting regular discussions, where to host those, and who will lead those long term. This is kind of a side project for me, so it's hard to commit to being kind of the full-time leader here. The core kernel, just a couple of things. Generic ring buffer for the kernel was proposed. I don't know if that's been actually accepted yet. I already talked about runtime const and some of these new mechanisms in the kernel for rewriting the kernel code at runtime. Graphics work. I think I mentioned this one before. There was a good talk about the Raspberry Pi GPU, um, and some of that, how that work got upstream, and and what was involved in that. Something that there was a good talk at ELC Europe 2024, so this is just 2 weeks ago, on Mesa 3D, and that talk covered core API, the state tracker, the dispatcher, the shader compilation. So a bunch of details that if you're getting involved with graphics, especially the GPU level, um, this is the OSS implementation of the OpenGL API. So oh, it says OpenGL AI. That is the wrong. Um, so file systems and I/O. So there was a block I/O speedup that was added in 6.9, and what this was uh, there was they one of the things that you have to do when you're doing block I/O is keep track of timestamps. And they realized that they were calling this routine to get the time, like every time they did a block I/O, and they realized they could cache that time, that timestamp value. And that actually helped quite a bit. I mean, 6% performance improvement just by caching one of the pieces of data that they were calculating on every block I/O. So that's a pretty nice thing. The other thing was that at ELC 2024, there was a really good talk on maximizing your SD card life, how to monitor that, how, talking about that talk had a great overview just of how the SD cards and NAND flash works, and write amplification, how to measure it and how to avoid it. So if you have SD cards in your embedded product, that's something to look at. Um, in networking, so there were a couple of talks at ELC 24. These are back from April to look at, and then in plumbers they had a whole networking track. And I'm not a networking guy, but a lot of these looked kind of interesting. If you're doing networking and kind of want to stay up to speed on kind of where the current work is going on, there's energy efficient Ethernet, high availability, seamless redundancy, and HSR protocol, which is like sending packets over. It's kind of like what would I call it? It's kind of like RAID for networking. It's dual, when you have dual channels, and making sure you have seamless redundancy. And then reasoning about cache usage of the network and the state of buffer bloat. So buffer bloat is this problem that they discovered, I don't know, it's been a while now, but that in routers, you have these buffers that accumulate, and you have to be careful. And so they're analyzing that and a whole lot more. So if you're interested in networking, I recommend that you go look at that session list and see if there's anything of interest there. So power management. In this technical topic area, there was Theo Lebrun, and I can't remember what company he's with, but he had a very nice talk, just giving an overview of power management features of the Linux kernel and the different interactions. So it had a good overview of the PM structures in the kernel, in particular the device PM callbacks. So the types of callbacks that the drivers have to provide, in order to support hibernation, suspend, resume, and runtime PM. And he talked about dealing with system-wide suspend issues. So that includes standby modes, hibernation, how to deal with clock issues while you're going into suspend. And then, so that's for suspend and hibernate operations. And then there's, of course, runtime PM. And the main topic here was about some of the features of the Linux kernel for enabling and disabling runtime suspend on a per device or per driver level. So that's a really good talk if you're just getting into PM. If you're an old hand, you may be interested in the next couple of things. So Stephen Boyd had a very interesting talk at ELC Europe, where he proposes a new Well, an SoC power management driver. So he says that device tree systems have this problem where a lot of the power management code is spread throughout the different drivers, and it's very difficult to manage. And so he says on ACPI systems, ACPI has a power management layer that drivers can take advantage of, and you don't have to have all this detailed stuff inside the individual drivers. And he listed a bunch of problems but one of them is that the overall SoC power state is kind of unknown to individual drivers, and so you can't do things like actually turn the power off on unused devices because there's no driver that knows about the other unused devices. It's kind of not their job to deal with that. And so he actually is proposing a new system that would be a driver that's a per SoC driver that can manage PM domains. And he gave a lot of details in this talk. So it's a very interesting talk. And I think he's going to make some progress with it. He showed the types of features that would add, and they look pretty good. The other thing that actually is now upstream is called PowerSeek, or it's a new subsystem that was added to the 611 kernel, and this is a power sequencing subsystem. Luckily, there's a talk on this at Plumbers that you can go look at. But the basic issue is that on startup of a machine, there are some devices that are not discoverable until their buses are powered up, but they're specified in device tree. And so there's these race issues. There's this chicken and egg problem where the bus isn't powered, the device might be powered, or it's like, when do you power the device versus the bus? And how can you if the driver is trying to be loaded, it doesn't know that there's this other dependency. Those are all, you can express these types of dependencies in device tree, but it's very awkward. And so he has introduced this new subsystem, and actually it's in the kernel now. And he's got an example actually running on the PCI bus. So this example that he provides, he's got the code for that upstream already. And some drivers are already starting to use this for Bluetooth, for devices on Bluetooth and WLAN. And he expects that there seems to be some pent-up demand for this, that this is a problem people have been seeing. And so power sequencing is something that is now available in the 611 kernel. Anyway, that may be helpful. Okay, so Preempt RT, we got to talk about this. This is exciting. So what's left in Preempt RT patches that are out of mainline? And the short answer, and almost accurate, is nothing. I've been talking about this for 15 years. The patch set was in development for 20 years. The final enabling patches were accepted for the 612 merge window. And this is the longest out of tree patch set in the history of Linux, maybe in the history of computing. I don't know. But it was such a big deal that Linus said, if you're going to give me a pull request, I want to see it wrapped in gold and tied with a bow. So Thomas Gleixner did that. He took his pull request, he printed it on a piece of paper, he wrapped it in gold and tied a bow around it, and then he handed it to Linus Torvalds with a bow. And this was at a little after conference party that was in Vienna. So that was kind of a fun moment. Anyway, so Preempt RT, it's upstream. I can't believe I'm able to say that sentence. So now that's the good news. Okay, admittedly, there are a couple of things still out of tree. You can turn on Preempt RT now and actually use it as is. But there are some ARM and PowerPC patches. There's a couple of remaining PrintK tweaks. The PrintK code was the last code to go up, the threaded consoles for PrintK. And so, but there are some, there's some bugs. But this is just like any other kernel subsystem. So every other kernel subsystem has stuff that's under development, tweaks. So there are still patches that you can get. I don't know if they're going to convert the patches into like all the others have kind of development trees, right? And with a branch that says next for that Linus pulls. So I'm not sure exactly how they're going to modify that. There was some discussion about that at Plumbers. But the preempt RT is upstream. It is finally upstream. There was some really great discussions at Plumbers about that. So what continues though, there is still work involved here. So you still have to find bad locking constructs in individual drivers because those can creep in. There's continued removal of the per CPU lock in local bottom half disable. So if you're using preempt RT, even if it's not the top of tree one, even if you're not in the 6.12 kernel, which you're probably not right now, but whatever kernel you're on, be sure to continue to report bugs because real use cases will expose bad latencies on certain code paths. So just because it's upstream, it's not done. And it's like like I said, it's like any other subsystem. None of the other subsystems in the kernel are done either. But now it's upstream at least. And so that's really nice. There are some really great talks at Kernel Recipes. There are two talks in particular at Kernel Recipes, which was just last week in Vienna. So Preempt RT Over the Years by Sebastian A. Ciawar and Making the Kernel Suck Less by Steve Rostedt. And both of these talks really are good, giving a history of the various RT-related patches and the features all the way back from 2005 to the present. And Sebastian's talk included some really interesting examples where preempt RT is being used. We know it's in use, but he had some pretty interesting examples of real-time potato filtering and an actual laser welder. So real-time critical tasks that are important. And so it's already it's been in use for years, but I think it'll see even more use with the patches being upstream. So, but we're not done yet. So there's more to do as always. There's if you want to see kind of the current research tools and analysis that the real-time developers are working on, there was a micro conference at Linux Plumbers. And there's a live stream recording. They haven't broken up the videos yet, but if you want to look at that live stream recording, the actual real-time microconference starts at 5 hours and 30 minutes in. So you can find the talks, but you have to seek to them yourself. There's a lot of analyzing of real-time behavior. So just because this stuff is upstream does not mean that your app will work properly. You do have to analyze your app, and you have to, work hard to avoid behaviors in your app that will cause problems. So a good example of that is if you make the read system call, you may or may not violate RT. So if you're reading from in a memory, a TempFS or a memory-based file system, it might work fine. If you're reading from a spinning disk, it'll be too slow. So there's other things that are outside the scope of just the kernel code path durations. So there's been talk about more work needed on thread starvation and priority inversion and all that stuff. So this is the point I want to make. Just because the kernel now has deterministically short, non-preemptible code paths doesn't mean apps won't make RT mistakes. In fact, a lot of the business that Linutronics does is consulting on RT, with developers who are doing RT systems. The application itself, how it's coded and structured, and what services it uses in the kernel is very important. So the focus now is on continuing to eliminate RT bugs and make it easier for app developers to write RT-safe code. And some of that is detecting problems and writing tools to help developers. Anyway, so that's real time. That's pretty cool. So in terms of security, there was a whole system boot and security microconference at Plumbers. I'm not going to go into the details here. If you want to see what sessions, this particular session microconference was a lot on secure boot. Basically, there's a lot of platform-specific problems with secure boot. Just so generic systems are pretty difficult. The bootloaders, UEFI and U-boot and other bootloaders are they're kind of behave differently on different platforms. And then another security talk that was actually pretty interesting was a review by Keys Cook about the features provided by toolchains for securing the Linux kernel. So this is a chart I stole out of his presentation showing a lot of these features. On the right is zero call used registers, structure layout, randomization. Which of those features are supported by GCC? Which are in progress? Which are supported by Clang? And then because Rust is now in the kernel, you also have to support them in Rust. So and these are a lot of the kernel security is coming about because the compiler has support for securing various aspects of the stack or structures, boundaries, and things like that. And so there's good talk on that. In terms of testing, I gotta pick up the pace here a little bit because I've only got about 20 minutes left. There were lots of talks on board farms at ELCE, and there was a testing microconference. Some of the topics on testing were adding benchmark results to KTAP, standardizing KTAP tooling, device tree testing. A really good talk on analyzing the existing test coverage. So that is a good. So that's talking about how the existing suite of tests that most people run, like LTP and K-self-test and K-unit, what code coverage are they actually getting? And in some cases, it's pretty good. In other cases, in other areas of the kernel, it's pretty weak. And so this is actually an academic paper. It was pretty interesting, showing where the kernel needs to improve in terms of its test coverage. And then there's talks about recent work in kernel CI and how to convert CI results into actionable reports for upstream maintainers. So this is I had to throw this in. This is the talk I actually gave on adding benchmark results. I'm not going to go into the details here. I could give a whole talk on this. In fact, I did give a whole talk on it at Plumbers. But I think this is something that's will be really useful in the future. Then let's talk just a little bit about tool chains. So one thing that was interesting was that the kernel devs usually invite the GCC developers to come to Plumbers, and they actually did. But the GCC developers have their own conference called Tools Cauldron, GNU Tools Cauldron, and they invited some kernel developers. So we went the other way this time. And so there's a bunch of discussion items at that event talking about various things: static analysis of the kernel, struct layout randomization, unwinding of user space stacks, hints from the compiler for better live patching. So there's a lot of really good work going on, a lot of good collaboration between kernel developers and toolchain developers. There was a toolchain track at Plumbers, a lot of focus on optimizations, but also support for security features, runtime environments, build services, and much more. Okay, so now on to tracing. So there was a good talk about system profiling, tracing, and analysis with a new tool from I don't know how new it is actually, but I had never seen it before. It's called Perfetto. It's a tool from Google, but it's available as a layer in the Yocto project. So if you're using Yocto for your embedded, you can actually get access to this Perfetto tool. It's kind of it's a browser-based front end, so which is what you'd expect from Google, right? So, but it's allows you to get traces out of your kernel and do visualization on them and stuff like that. And then another thing that I noticed, I was talking to Steve Rostat, is this persistent traces across a reboot or a crash. This allows ftrace buffers to be placed in memory that survives a reboot. So that means a second instance of the kernel can read the trace data from a previous instance. Looks like it went into the kernel in either 6.12 or 6.11. I checked for it. It's in the kernel now. I'm not sure exactly when it went in, but that is pretty interesting. So if you're doing tracing. And I'm going to skip over the build tools. I think I talked about this last time. Yocto project had a new release in April, and people are adapting to it. Okay, so let's talk a little bit. So sorry, that was really fast. I'll slow down a little bit, but not a lot. I got some more stuff to get to. I'm just going to talk really quickly about trade associations and some miscellaneous news. So Linux Foundation has all these different projects that are related to specific vertical areas, like drones and automobiles. Kernel CI is related to testing. ELIZA is about safety critical stuff. And then you've got like OpenChain working with supply chain issues, and OpenSSF doing security. And then, of course, Yocto project to build system for embedded. The only one I drilled down on this was automotive grade Linux, because they had a nice status update at Embedded Linux Conference Europe. Walt Miner and Scott Murray talked about their latest release was Royal Ricefish. This was released in July. They talked about the challenges they had migrating to Yocto Project 5.0, but they have completed that. And in the process, they fixed several of the bugs in that release. There's more support for Flutter as a graphic library, and they actually now currently support a Raspberry Pi 5 as one of their boards, which should make it a lot easier for kind of hobbyists to get involved and kind of play around with the system, because obviously Raspberry Pi is a pretty accessible board. Just a couple of things in the miscellaneous category: live Bootstrap project, a new root commit company, and a new BusyBox release. So I saw this article on lwn.net. So there are people in the world who want to have a secure system that they have audited like every line of code. There's a very old paper called Trusting Trust, I think by Ken Thompson or Dennis Ritchie or someone, about how if you haven't built the software yourself, if you're using binaries to build things that you did not build yourself, then you really can't know that it's secure. So there are several projects that allow you to start from just pure source code and very small hex operating systems, and you start with a non-Linux kernel that you can inspect and assemble manually, and then you use a series of bootstrapping steps. So first you build a C compiler, and you have to build it without using itself as a binary, and it's very tricky. But the goal is a 100% human auditable system. So if you are interested in that, you can go check out that lwn.net article. The other thing is there's a new embedded Linux company out there, Root Commit. So I don't know if some of you probably know Michael Optenacker. He's been around the embedded Linux industry, for almost as long as I have, I think. But I think I first met him in 2006, so over 20 years ago. So he was previously the founder and CEO of Free Electrons and Bootlin, and I think he sold off that company, and he now does training and consultation work at his new company called rootcommit.com. And he gave his first talk as the sole employee of that company, his new company, at Embedded Linux Conference. So, but he's still around the industry. I saw his thing on LinkedIn. Anyway, just a little bit of tidbit there. And then BusyBox 1.37. So this is the first release BusyBox has had in 1.5 years. So they're going kind of slow, but there are improvements. So there's been improvements to Ash, which is their minimal shell, and awk, in particular math fixes in the shell. They have an NTP client and server that are now year 2038 safe, and a new applet for Git extended attributes, get fadder. And so if you want to read up on that, if you want to upgrade your BusyBox, there's a new version, and I'm sure it has lots of bug fixes and other things as well. So the community, let's talk about a couple of things here. Conferences, a new Bootlin podcast, and the eLinux Wiki. So conferences. So like I said, we just barely had ELC Europe and Linux Plumbers, and then I'll talk about the other ones that are coming up shortly. So Embedded Linux Conference Europe was in 2024. It was just September 16th and 17th, so 2 weeks ago, 2.5 weeks ago or so. Um, it was a smaller event this year. It was a mini summit or mini conference, really. It was 2 days and two tracks instead of the 3 days and three tracks. So the slides and videos will be on that eLinux wiki page that I have there. Again, it's not populated yet. I kind of said this already, but I'll announce when the videos are available. The videos usually take 2 to 3 weeks, so they could come out anytime. But we'll get the individual YouTube videos available shortly. And in the meantime, you can, if you want to go, you can find the slides by looking at the sketch.com page for the event. So it's the Open Source Summit Europe 2024 sketch.com site. But if you use this URL, it'll filter them down to just the embedded Linux talks. So my impression was it was a good conference. I enjoyed it. I got a lot out of it. Content was good, but is not as much as usual. Um, so anyway, it was a kind of a mixed bag. The reason it was smaller is because of Plumbers. So Plumbers was actually quite a bit bigger this year. So Plumbers was from September to 18th through 120th. No, that's not right. 18th to the 20th in Vienna, same location, and so they kind of squeezed us out. They had 24 micro conferences, 5 tracks, refereed track, kernel summit. I think I don't even have the toolchain one on there. Anyway, but over 250 talks or sessions. So it was a huge event this year, much bigger than usual. Well, about twice as big as usual. So the slides and videos are available. Well, the videos are the same thing, not broken out yet. Some of the room live streams are available. If you know where to look, you can find the room live stream, and then you have to scroll over, seek to the hour where that talk was. Sometimes it's several hours into the talk, into the live stream video. But those will get broken out and made available. My impression on this is the content was very, very good, which is very standard for this. Is kind of the event for kernel developers go to. There's way too much going on though to take it all in. It's not like I don't know if they have this in Japan, but in the U.S. they have a 3-ring circus. This is more like a 7-ring circus. There's too much to look at. And luckily, question mark, only a small portion of the event relates to embedded. So you can kind of see all the stuff that's related to embedded. Well, you may or may not. But it's a really good event to see what the server and enterprise developers are doing. And see, in particular, how they might be interfering with your embedded plans for the future. So some of the conferences that are coming up soon, we have Open Source Summit Japan coming up at the end of this month. So that is excited. And actually, I will be in Tokyo for that. So I hope to see some of you in person. FOSDEM in Brussels is in February. It's usually the first week of February, so not a surprise there. Embedded Recipes is a smaller event, but it's expanding to 3 days, and it'll be in France in May. And then Lenaro Connect will also be in Europe, Lisbon in May. So hopefully those don't conflict too much. And then some of the bigger events, Open Source Summit North America will be in June in Denver, in the USA. Probably we will not do a full-blown ELC. Well, almost certainly we will not do a full-blown one. We may do some mini conferences on dedicated topics. The reason for that is we're focusing next year. We're going to focus on a full-blown ELC at Open Source Summit Europe, and that'll be in Amsterdam in the Netherlands the end of August. And so June and August are only 2 months apart. It doesn't make sense to have but try to get embedded people to come to both of those. But for a dedicated topic, there might be some mini conferences in North America. And then here's a bit of news you may not be thinking of yet because you haven't had Open Source Summit Japan this year yet. But next year in 2025, they've already got the dates, December 8th through the 10th And then Plumbers is going to be in Japan. So there's some exclamation points there. So, and they're not overlapping, which is good. So this year, Plumbers overlapped with ELC, and so it caused issues. This year they're separate, but that does mean if you look at the dates, that means Plumbers is going, I think, Thursday, Friday, Saturday. So Plumbers will be on a Saturday, or one of the days of Plumbers will be on a Saturday. So, but that's great. Usually it oscillates between North America and Europe, but they've decided to come to Japan. So, and I've heard a lot of people from Asia, people in China and Japan are excited about that. Well, those that have heard, that hasn't been formally announced yet, so you heard it here first. Um, uh, so that's conferences. Just a little bit on podcast. There's a Bootlin has done a lot, has a lot of great free material available. They just started this last week, or this week. They started doing a podcast on the status of embedded Linux. There, so I don't know how often they're going to do this, whether it's like once a month or quarter, or I don't think they're doing it every week. But anyway, you can go see this podcast that they're doing. They did a report on Open Source Summit Europe and on Plumbers. They gave their view of Plumbers and stuff. And then they talked about the Elixir source browsing tool. If you've never used Elixir, it's a great tool for browsing the Linux kernel source. And I was surprised. I didn't know this. I've used it before on the kernel source. It's for browsing symbols, and it makes it really, really easy to, if you're looking at some code, to go to, where is this defined? Where is this function called? Who calls this, etc. But the thing I noticed this time when I was using it preparing for this presentation is that it has code for a bunch of stuff. It has code for U-boot. It has code for Barebox, Grub. I think it has code for GCC. So it actually has more than just a Linux kernel. So a great source browsing tool, especially if you're new to the kernel. I recommend it as a way to kind of learn a lot about the kernel. So that's a new podcast. And then the eLinux Wiki, of course. This is the same slide I had last month. I haven't changed this slide, but we did have an eLinux Wiki BOF, Birds of a Feather session at Embedded Linux Conference, and so we have some ideas for improving the site. We do have some funding that we can use, so we'd like to see about getting some actual paid, some volunteers to help with the site, and maybe actually pay some people to help with the site or generate content as well. So that's something that we hope to continue to build up. I know I'll be putting a lot of boot time information on it. So at least that area is going to make the site worth using if you're doing boot time. So just some conclusions. These are the same conclusions I have every time. And we're doing great. Overall, we're doing very well. Embedded Linux is used widely. It's widely deployed and functional. It's used in billions of devices. I actually heard, I've said this before, we used to say, the goal of Linux was world domination, but we stopped saying that once we dominated the world. And Linus Torvalds actually said something very similar to that. He and Dirk Hoendel had a keynote session at Open Source Summit, and he said the same thing. He says we used to talk about world domination, but now we've kind of dominated the world. That doesn't mean our work is done, though. So even though the core kernel systems are in place to support embedded, and we're using Linux in tons of places. But new hardware keeps being made. There are new places to put Linux. I've just been recently involved with a new effort by the Linux Foundation, the Space Grade Linux work group that's part of the ELISA. So we want to put Linux in even more places. I can't believe after all the time we spent on Linux, we're still not done. But anyway, it's a great system. So here's some of the resources that I use. I look at lwn.net and Phoronix and the eLinux Wiki, and especially the event pages there, and also Google and kernel mailing lists. And anyway, so That's it. Oh, this is my final resource for kernel information. Uh, this is lwn.net, the actual kernel index. So I have an index of every article they've written, and they've got it sorted by topic. So this is really handy if you want to learn about USB or what's on the control flow integrity or integrity verification. Those are the ones on the screenshot I did there. Any topic you can imagine, there's material that's been written about over the years on it, and so highly recommend that. And that's it. So thank you very much for your time. I have, I think, maybe 2 minutes or so for questions. So are there any questions?
鈴木さんかなコメントが。
Oh, is there a chat? Let me see.
手挙げてますね。鈴木さんどうぞ。ミュートのまま喋ってるのかな。うん、手挙げてるよね。鈴木さんどうぞ。
鈴木さん、you're muted.
ああ、そういうこと。でもなんかね、チャットでコメントがみたいな。
I see that someone has posted the link to the 6.11.1 source for Elixir. Yeah, so that's a good link in the chat box.
うん、コメントかもしれないけど、何かあれば。手が下がった。
Suzuki-san, could you introduce or translate Suzuki-san write in the chat box of his question?
Oh, okay. Yes, if someone could translate that.
Okay, I'll translate. Recently, from the security perspective, a proc or temp file system is used to vulnerability or attacks. So instead of using proc or temp file system, Unix socket or named pipe is used. Sorry, I don't know, but yeah, Unix socket and named pipe is used to be the vulnerability. So it should be refined or not used these technology he mentioned. Well,
Okay.
do you have any thought?
I don't. I know that ProcFS does have some known vulnerabilities or not some weaknesses. I'm not sure how people are working around those. Um, that's not something I'm super familiar with. There was one discussion I know. There was an issue that came up in one of the sessions I was at Plumbers having to do with the pivot root at boot time. They said they might restructure that. I guess the initramfs or the initfs comes up with on one system, and the way it pivots to the other system might be a security problem, and they were going to change some stuff there. That's all I know about that. Yeah, as far as reconsidering the functionality, a lot of functionality has moved out of ProcFS to SysFS. So ProcFS, I don't want to say it's deprecated, but it's a lot of the critical stuff has moved out of it. And there is a lot of work going on things like namespaces. So one of the things that I saw, which so there are file system namespaces, or I'm not sure what they're called. I don't know if that's the right thing, but there are ways to containerize the application so they can't break out to other people's file systems. So, like on my desktop system, every user has his own temp, and so I think there have been some security mechanisms introduced for the temp file system. Other than that, I'm not an expert in that area.
Thank you, Tim.
他何か質問、コメントある方いますか？はい。
Thank you, Tim, for your presentations. My question is one of the most important aspect for the real-time Linux project is mainlining RT-Plane patch set. So I think it's now almost finished. So are there any discussion was made in Plumbers for the project?
Oh yeah, in Plumbers there was a lot of discussion. So one of the I was in the if you look at the real-time micro conference, I don't know if that live stream is available, but there was a lot of online discussion there in that room. One of the things I thought was kind of funny was Thomas was someone said, "Oh, this is such and such is an issue," and they asked Thomas for his reaction. He said, "Well, it's an upstream problem now." So, I mean, so let me. I'll speak kind of frankly. So, Thomas is getting older, and I don't think he's going to completely remove himself from development, but I think he is getting closer to retirement age. And one of the things I thought was interesting is that although he's really heavily involved in a lot of the technical decision making, a lot of the people doing the day-to-day management of real time are two other developers. One is John Agnes of Linutronics, and the other is Sebastian Siawar. And I thought that was actually really good. Both of those developers were there at Plumbers, and I think that work is going to continue on real time, even if Thomas kind of takes a lesser role going forward. So that we didn't talk specifically about succession there, but I think that there is already a plan in place, or the people are there to take over if needed going forward. And I did have a chance to talk briefly with Thomas in the hallway. He actually is looking at some other things in the kernel he wants to work on. He also does real time work, but he was very interested in sustainability uh, issues with the Linux kernel. So I think yeah. So there was actually a lot of talk about what happens now that it's upstream.
Yeah, thank you very much. Yeah, I think that this is a similar issue happens every subsystems.
Yeah.
Any other questions? Okay, thank you, Tim.
Okay, thank
I
you.
hope to see you in Japan.
Yes, I hope to see many of you in Japan as well. So.
じゃあ最後に拍手を。はい。じゃあ、少し早いですけれども、